All right, and we're ready to move on. But actually, just before we move on, there is one little term that I want to get across, and that is something you're going to hear time and time again, but most people don't actually have a clear understanding of what it is. It is this term called platform. So we've already looked at our 3-layer model. Well, actually, in IT, the bottom 2 layers of your IT model, that hardware and the operating system, when you combine them together, that is known as your platform in IT. So when you ask someone what their platform is, theoretically, they should come back and say, I am Windows on PC, I am iOS on Apple, I am something on something. But in most cases, when you ask someone what their platform is, they normally say, I'm a Windows platform, or I'm an Apple platform, something like that. But platform's a cool term. It's going to help us when we go into the next session here. All right, let's talk about cloud. Now, again, huge area. I've got an entire masterclass based on how to understand recruitment within cloud. But for now, we're just going to look at the fundamentals. And the first thing you'll note when you see anything to do with cloud is this term, something AAS. So XAAS, X meaning anything. And whenever you see the term AAS, usually written small a, big S, it can pretty much be assumed that you're talking about a cloud-based role. So everything as a service is cloud. And a very important architecture within cloud is infrastructure as a service. So IaaS, and it's something we've already mentioned earlier on. And what that means is, essentially, I don't want to take responsibility of my hardware. I don't want to go out and buy all these expensive servers or mainframes. So I'm going to relinquish that to somebody else. And that's what AaaS really means. That's what cloud really is. You are relinquishing your responsibility to elsewhere. But the level of relinquishing is dependent on yourself. So it could be that you just don't want to take responsibility for looking after your hardware, in which case you're just going to go for IaaS. However, you are still in control of your operating system and your applications. Remember our 3-layer model, so it's an important one. But what you've done is you've just relinquished the bottom layer, and that's important. Now, there, you have no issues with the IT department in terms of looking after the hardware, because it's somebody else's IT department. It's a very expensive part of the architecture. So somebody else is looking after all of that. However, it could be the situation where actually you don't even want to be bothered about the operating system either, the 2 layers. Now, you remember what our 2 layers were called, the platform. So sometimes you will see the term PaaS. And where that comes into place, platform as a service, it simply means, I want to do my own application development, but I don't want to be hassled with looking after the operating system and the hardware, in which case your cloud provider is looking after the bottom 2 layers, and that's platform as a service. Now, of course, it could be that you don't want to take responsibility for most of the architecture. In fact, you may want to use all your software in a cloud environment as well. So of course, there you're looking at software as a service. Now, it's interesting when you think of cloud architecture that even there, our 3-layer model still applies. It's hardware, operating system, application, software. IaaS, PaaS, SaaS. So it's interesting. Now, again, as I said, it's a huge area. How people look after cloud, how they implement cloud, the other terminology and the tools that are used in cloud recruitment. We've got an entire training environment just for that, the masterclass just for that, but we're not going to do that here. What I will do, though, of course, is quickly fill you in on the big cloud vendors you definitely need to know about. So the big players within cloud are, of course, Amazon, and their product is called AWS. They've got an entire suite of products underneath there, which we can go into in different videos, not here. Amazon is currently the largest cloud vendor, and they are also the largest IaaS vendor. So huge organization, a giant, and they've got clients like Netflix, Airbnb. They use their services on the cloud. So essentially a huge player, but they're very good at IaaS. Next one up is Microsoft Azure. Now, Azure may not be the biggest, but they are the biggest in software as a service. Okay, so Microsoft Azure, that's their speciality. There's Google Cloud, and Google Cloud is very good at the artificial intelligence side of things. So the AI and machine learning area is traditionally where they've got good. But actually now pretty much everyone is getting involved in AI, and that is affecting most of their product range. So it's worth you understanding AWS, Microsoft Azure, Google Cloud, IBM's there, Alibaba, these are all big cloud vendors as well. So that was a quick run through cloud. As I said, you can learn much more on the other videos, but let's carry on. So now that we're going to talk about programming languages, of course, you cannot be in tech recruitment and not come across programming languages. You are going to be recruiting developers at some stage in your life. And of course, we have a huge plethora of training just for this. There are mind maps relating to this as well. There are free mind maps relating to this. So you may want to, again, request those in the comments section because you want to join our resource library for that. But let's look at languages. So there are loads. And of course, the most common ones are things like Java, C#, JavaScript, and all of them have their own speciality. So without going too deeply into this, I will just go through some of these now, but this is an entire area of training in itself, and you need to know. Why are there so many languages? Well, all of these languages generally evolve because they have their own specialism. And so that's one thing to understand. Just like you and I speak languages, there are loads of languages from Mandarin to English to French. Now, we all have our nuances within there, and there are reasons why that language may be good at a particular thing. English is widely spoken around the world. It has its strengths. Mandarin is spoken widely around the world, and the structure of Mandarin is completely different from the structure of English. So actually, just because you speak English, it doesn't mean you can speak Mandarin. The syntax is different. So there are two different families of languages there, and it's the same with programming. So in programming, you have a syntax, and people who know one syntax are usually going to be very good at that family of languages. The original C syntax is the syntax that really has won the day in terms of good, strong, modern languages. And so one of those languages that is based on the C syntax is Java. Java, very popular around the world, and there is a key reason why. Java was really effectively the world's first platform-independent language. So now we're bringing terms together. We understood what platform was, and here is the irony with development, and it has been for the last 40 years. When you develop an application historically, you must always develop it with a particular platform in mind. And so historically, those applications that worked on a Windows environment, you would have had to redevelop again to work in an Apple environment. Angry Birds for Android would have been different for Angry Birds for iOS. So the developers would have developed that again and again. Now you can see this is a real pain. The more devices that are created in the world, the more operating systems that come out in the world, it becomes more of a problem for developers. You have to develop the application time and time again. And then someone came up with this language called Java. And Java achieved the nirvana of languages or software development. W-O-R-A, Wara. Java, its beauty is that you can write once and it will run anywhere. Write once, run anywhere. That is a godsend for developers because suddenly you can develop your application in Java, and Java has this beauty of being able to come down on other platforms. So essentially, whichever platform you put it on, Java will run. That saves you time, money, deployment costs, all the rest of it. So Java, a huge paradigm shift in languages and a huge commercial success because of that. Now we can go into that on another video. Indeed, I've got other training on that, but not here. So Java is one. Now, it should be worth noting that Microsoft achieved the same thing through their language called C#. So C# is the Microsoft competitor to Java. Loads of other languages in play, of course, things like JavaScript you're going to come across. Weirdly, just to make it interesting, JavaScript has nothing to do with Java. It is a scripting language. And again, this idea of scripting, the idea that you can make small, repeatable pieces of code, JavaScript does that very well. It is the world's most popular scripting language, and in some leagues, actually the most popular language in the world in terms of development, depending on which rankings you look at in 2024. Other languages exist, including Python, and they all have their strengths. So for example, Python is said to be easy to learn, very, very flexible in where you can apply it. And so you will see Python being used in anywhere from data science to machine learning to web applications. So some of these are very flexible. I'll give you one more. C++ is one of the older languages, still around. Now, you remember I mentioned real-time embedded systems like microwave ovens, IoT devices. Well, C++, along with C and a bit of Java, C++ is a very good language for real-time embedded systems. So if you're a developer in the real-time environment, very often you're going to see C++ as the language of choice for that developer. I'll leave it at that because we could go on forever with languages, and we will go into that in other videos. But there are a plethora of languages. We have got mind maps relating to all the languages and what you need to know about them. So again, just request them in the comments. So far we have looked at the three-layer model of IT. We've kind of quickly gone through cloud terminology, and we've taken a good look at languages as an intro. But one thing you cannot really do in technical recruitment is move on without understanding the whole concept of how people make IT, how people create a software, how they lay out a network, what is the methodology they use. And believe it or not, methodologies are a huge thing in technical recruitment, and you cannot really recruit unless you have a full understanding of those. In another video, I'll explain all the various stages of Waterfall and exactly how they work. But for now, you need to understand that Waterfall was the older methodology. It was very structured, but invariably it came out with products that were obsolete by the time they were created, because Waterfall often went on for 2 years, 3 years, 4 years, even 6 years to actually create an IT system. Now imagine today, in that sort of innovative environment that we're living in, you can't have a methodology that knocks out IT systems in 6 years. However, there are situations where Waterfall is still used, because you can think not every IT system can be knocked out quickly. But if you want speed, you come away from Waterfall. If you want agility, if you want flexibility, you come over to other methods, such as Agile. Agile, Scrum, Kanban, these are all ways of creating IT systems, but they're ways of working which allow much more flexibility, and importantly, they bring in the user. So where Waterfall actually speaks to the user at the early stages and then effectively leaves them alone for quite a long time, with Agile and Scrum, it's a new way of working. And indeed with DevOps as well, it's a way of working where you bring in the users and get them to continuously input into the system. And they input into the process, and once you've got that done, then effectively the product is launched. But the product is not left as it is. You can throw the product back into the development cycle. And so these latter methods like Agile and DevOps allow you to evolve the product more. Agile knocks it out quickly, but DevOps definitely has a focus on creating products that are much more faster, to date, very innovative, using the latest technologies, and always relevant to the end user. So that is very, very powerful indeed. Now, again, in other videos, I'm going to go through all of these methodologies in much more detail, and we have mind maps and training videos in our community. So again, just request to join and we'll get those across to you. But for now, understand that methodologies are a huge part of creating IT systems, and you definitely want to know when you go into a client site to ask, are they working in an Agile environment? Are they working in a DevOps environment? Do they prefer Scrum? Or indeed, are they one of the more structured approaches like SSADM or Waterfall? Whenever they mention any of these are ways of working. Very important for you to know. Now, we've mentioned programming languages, but we haven't really gone into this idea of libraries and programming and how they join up. I have indicated that today there is a lot of reusability of code. It is really all about the reusability of code. Now, you will often hear terms like low code, LOCODE, or no code. And in fact, it's a very interesting time we find ourselves in 2024-25 because of the rise of AI. Because if you have philosophies where you can just go out and pick pieces of code and no one's creating code from scratch anymore, well, why couldn't an AI system do that for you? And this is where programmers are finding themselves in today. There is a kind of almost an existential crisis in programming as we speak, because AI systems are using this idea of reusability of code, and they're creating products in a fraction of the time that a human person would do that. And so we need to understand, again, it gets back to this idea of reusability. Now, I mentioned concepts earlier like scripting, object-oriented programming, but what you really need to get to grips with is the idea of libraries and frameworks within programming. So let's explain those first. So what is a library? A library is a collection of small pieces of code. That's the best way to think about it. Libraries are collections of small pieces of code that can be used again and again. Now, a lot of people confuse libraries and frameworks. And to be honest, it's not a huge faux pas. If you get it wrong, it's okay. But to really understand the difference, libraries are small pieces of code that you can use again and again. It's where people put those codes. Frameworks are more than libraries. They have much more in them, and they will show you how to use those pieces of code. So contained within a framework are instructions on how to use those pieces of code in the way that this company wants you to use them. For example, in the .NET framework from Microsoft, the language you will find in there is C#. So C# is the language, .NET is the framework. Now, very often you will see that happening. You will see a language and you will see a framework. Python with pandas. You will see that. Java with Hibernate. And this is an example of how libraries and frameworks come together. Languages and frameworks come together. So very often in your job spec, they will mention a language, but they will say we need them to have this particular library or this particular framework. And I'm going to give you a list of these now. So libraries are collections of small pieces of code. Frameworks can be thought of as toolbox with instructions on how to use those pieces of code, but actually there's a lot more in that framework. And the best way to remember this is that you can have frameworks that contain libraries. You will never have libraries that contain frameworks. So frameworks are a bigger entity. They are often given a name and by a vendor, and so you can download the entire framework, and within that framework you can have libraries of code. That's the best way to remember them. Okay, frameworks are the bigger entity, libraries can be contained within the framework. How do programmers use these? Well, they will download the framework, let's say from Apple or let's say from Microsoft, And when you use the Microsoft .NET framework, it will give you clear instructions on exactly how Microsoft wants you to use their pieces of code. Make sense? Now, there are open libraries and so open frameworks as well, and these are created by people who aren't necessarily commercial companies. So for example, Spring and Hibernate are frameworks for Java, but they are actually free and open. Let's look at a list of some of these now. So for example, for Python, there is a powerful library for numerical computing, and this is huge. For heavy mathematical operations, there is a library called NumPy. For JavaScript, there is a library that provides great functionality for working with objects and data types, and that's called Lodash. It's a JavaScript library. But another JavaScript library is really much better at creating user interfaces. So it's looking at the layer that you and I see, the user interface, and that is called React. A library for heavy data manipulation in Python is called Pandas. And so if you're working with a machine learning role or job spec, very often they will ask for Python with Pandas. And that is all about large amounts of data, understanding that data, manipulating that data. And the Pandas library is great for that. But in Python, if you want to make much more web server-based requests, then you may just go for the requests library from Python. So that's essentially what that is. However, using the Python language, you might be much more interested in creating visualizations of data like graphs and charts. And so in that situation, you would use a library called matplotlib, very common, all right? Python with matplotlib. So you can see very often on CVs and job specs, you're going to see a language and you're going to see the corresponding library. You can ask the developer or indeed the client what that library might be specialist in, what it's used for, and they wouldn't have a problem with telling you that because most libraries will have their own specific functions. Now, let's just flick over to frameworks, which we said was a subtle difference in terms of they will have more than just what the library has. So for example, with Python, there's Django, and that's much more for building robust web applications. Different libraries do different things. JavaScript libraries include Angular and Node.js. So very often when you see something with .js, it means it's a framework for the JavaScript environment. You might want to create web frameworks with Ruby. And so then you would use Ruby on Rails. You can see when there's something with something, it's usually a language with a library or a framework. And so that's something you just need to get used to within software development. So there are loads of libraries, loads of frameworks, and of course, it's not a huge issue if you kind of interchange them too much. People aren't going to take you up on it, but it's great for you to understand that this reusability of code in most languages results in libraries and frameworks. And developers use these all day long to create applications very quickly rather than writing things from scratch. And very often, the libraries and the frameworks will have their own particular niche and the particular scenario that you might want to use that library or framework with. Very important. All right, we are rocking along. So we're going at quite a pace now. So we have done cloud, we've done languages, we've done frameworks and libraries, and we've done the big model of IT, but we haven't touched on data. And you cannot be involved in tech recruitment without really understanding the whole idea of database recruitment. Again, there are other videos relating to the masterclasses on this area here, but today we are just going to go through some of the key terms you need to know. The first term is RDBMS. Relational database management systems. To be honest, everything you deal with in tech recruitment, most of them will be something like an RDBMS system. So what is an RDBMS? It is the modern version of a database. So most databases today are RDBMSs that you will have come across. And what that means is they use tables and rows and a language called SQL. Wherever you see the term SQL, that is data at play. So if you've got a job requirement or a CV that is going mad on SQL, well, that is a database expert in some form. And RDBMS databases rely on the structured query language to go backwards and forwards and bring the data back for you. You are probably using SQL, you just don't know it. So if you are typing in, find me all the Java developers in the London area under 50 euros an hour, enter SQL is interrogating an RDBMS database, such as SQL Server or Oracle. However, and again, this is a huge area which I will explain in other videos or on other trainings, but a lot of databases are no SQL. And what this is a complete paradigm shift from what has gone on for 40 years. Because the key thing with RDBMS databases is that they were only good for words and numbers. You cannot really do the exciting stuff that we want today with RDBMS databases. And this group known as the NoSQL group realized this quite early on, and they said many years ago, listen, there'll be a time when find me all the Java developers in the Munich area under 50 euros will not be the interesting search. The more interesting search is, how does someone move through a shopping center having drunk this the night before and had this to eat? How will they vote? So this is where you are bringing all sorts of other things into play, maybe such as geolocation, images, video. The new area of databases is not only SQL, no SQL databases. Databases such as MongoDB, Cassandra, Hadoop, all of these are bigger concepts than just RDBMS. We'll go on to that in a different video. But for now, two big types of databases, RDBMS, still used widely, and NoSQL. The big RDBMS players, Oracle, Microsoft with SQL Server, MySQL is the free and open version of those databases, and PostgreSQL is there as well. We'll go into that in much more detail somewhere else. MongoDB, Cassandra, Couchbase are big NoSQL databases, much more flexible, much more fluid, much more interesting in terms of the modern paradigms of understanding data patterns. As we speak in 2024, one of the biggest growth areas, even with the advent of AI, is cybersecurity. So there are a lot of roles that are kind of being impacted with AI, and people within tech are asking themselves, what should I move on to? What new skills should I learn? But one of those areas that people should really get to grips with is an understanding of cybersecurity, because they still remain, it seems to be, the rock stars of the future in terms of tech roles. So what are the terms that you really need to understand? We've got a 5-hour masterclass on this. So of course, I want to go all over the place with this. But no, you only need to know the fundamentals here. So you need to know things like the attack landscape. What is the attack landscape? So this is like a criminal looking at your house and monitoring it and looking at the doors and the windows, all the landscape, to see the weakest part of your environment or your architecture. And hackers do this to large organizations. They will spend a considerable amount of time monitoring the attack landscape, so then they will know which method to use to get in. Because of course, every single company has different weaknesses in its technology. It could be its applications, it could be its operating system, it could be its hardware, it could be its cloud setup. And that's the way they will get in. Now, the way they get in is known as an attack vector. So there are numerous attack vectors. When you look at a cybersecurity role, when you look at a cybersecurity CV, you will see terms like, of course, phishing, but you'll see terms like malware, you'll see terms like SSL, man-in-the-middle attacks, you will see brute force attacks. All of these are terms relating to the attack vectors. SQL injection, which implies that you're trying to get into a database. So you'll learn all about attack vectors on our training, but for here, we just need to understand what an attack vector is. This is how we train up people within cybersecurity recruitment, because it is a massive area. Now, rather than getting into the nitty-gritty, I will leave this area of cybersecurity because there is so much I want to tell you, but we will leave it with just the pillars of cybersecurity. So these are the 3 pillars that most organizations will focus on when they're thinking about cybersecurity, and it actually is CIA. This is not the Central Intelligence Agency. These are the 3 acronyms that most focus on the security of your architecture as an organization. So in cybersecurity, we think confidentiality, integrity, availability. That is essentially the 3 pillars that most people want to focus on when they are first learning about cybersecurity. And everything I've told you, the tools, the attack vectors, the attack landscape, they are all based around securing this. We've covered quite a few terms, including languages, frameworks, data, but I'm just going to finish off here with one area, artificial intelligence. Now here you just need to know a couple of terms because of course this is huge. This whole area is the theme of our time, and I can spend 5 hours teaching you this stuff. Indeed, we have a masterclass on how to recruit AI and all the tools and the technologies that go with that. But for now, just understand one big term, machine learning. Machine learning is the way you teach computers how to really think like a person. So it gives an inanimate object like a computer the illusion of thinking like a sentient person like you and me. And how do you do that? Well, you just feed it vast amounts of data. That's what we do with machine learning. There is no AI without machine learning. Machine learning is the process of feeding vast amounts of data into computing systems and then teaching those computing systems how to spot the patterns within the data so that they can answer questions and maybe even see patterns that we don't see. So this is how you teach a computer how to think like a human being. This is how ChatGPT operates. This is how you teach a car how to drive like a human being. It's machine learning. The more complex part of that is deep learning. So very often you will see job specs within AI that ask for deep learning, and just like an advanced student, deep learning uses much more complex data algorithms to make decisions. Okay, so this is how you recognize a face in a crowd or a pattern within a medical group of data, and essentially spot patterns within that vast amount of data so that you can spot things like viruses and diseases that are taking shape. That is deep learning and machine learning. It's a huge area and I don't want to cover it here, but all of those things that we have just mentioned, if you've got those in place and if you understand those, the beginnings of understanding tech recruitment have just taken shape. And we are going to go much more into some of these topics in other areas, in other videos. But of course, as always, as I said, the best way to do this is to join our community, get to the resource, and make sure that you can download many of the mind maps and the other resources that we have, including PDFs, job descriptions, interview questions. So there's so much more that we can give you. Just put something in the comment section and we'll respond there and we'll let you know how. But in the meantime, I hope that's helped. I look forward to seeing you on the next video.